Cool. Okay, so it's great to be in Vilnius. I come to Lithuania a lot. My company partners with another company called Datadog in Kaunas. So I love Lithuania. I love being here, and I come here very often. So it's a real great honor to come and speak today. You weren't so interactive with the last dude, and it's probably because you're a bit Lithuanian. So please be a little bit more relaxed with my talk, ask questions. It's going to be very informal. I'll be asking some of you questions as well, so please do answer. Okay, so why is artificial intelligence hard? Before I begin, let me just tell you a little bit about myself. I don't usually like to do this, but it just gives me a bit more confidence. My background is I have an academic hat where I studied AI since I was 19. So I did my undergraduate, my master's, my PhD in artificial intelligence. And I run a master's program in UCL in London, which is applying artificial intelligence to solving business social problems. And on my other hat, I run a company called Satalia, which is a company that provides artificial intelligence solutions for other organizations. I've started a few other companies as well, particularly around taking very, very smart people, very smart things from academia, and getting them transitioned, being used in the world in some positive way. I advise various companies, including the Home Office in the UK, about how to use data for interesting things. Okay. So before I kind of launch into what AI is and why it's hard, I want to get us all on the same page with what data-driven decision-making is. Has anybody heard of big data, data-driven decision-making? First question. Okay, great. So this is how I think of data-driven decision-making. It goes from data to decision-making. And the first question that I have for you is, what is data? Ones and zeros. It's very rare that somebody answers a question right the first time. So very good. Data is just, exactly, in Latin it means given things. It just means stuff, anything. Very often people think it's facts or information, but data is just raw ones and zeros, stuff. It's not until you give it context, it's not until you give it meaning, does it become information. So let me give you an example. What's this? Huh? You see, this is going to be a difficult audience. Excellent. What's this? What does it say? Yeah, so the middle thing is the same thing, right? Your brain is interpreting this as ABC based on its context, and your brain is interpreting this as hopefully 12, 13, and 14 based on its context. So the same light is entering your eyes, the same data is entering your eyes, but you're giving it a different meaning based on its context. I can't remember the Lithuanian word, I keep forgetting it, but in the UK we have a word which means sick, which is called sick. Anybody know what sick is? What's the Lithuanian word? So if I tweeted my laptop is sick, what does that mean? Huh? Huh? It's broken, it's ill, but that's because I'm old and boring. But if you're young and cool, it's awesome. So this data, this word sick, can mean two different things. And if you're a business or somebody that's looking at this tweet, if you decide to retweet it because you think that it's good, then it could be a very bad decision. So you've given it context, and that context might be incorrect. Now, one of the hardest things we have happening in computer science right now is taking natural language, or taking images, taking video, and giving meaning to it. So if I take a photo of this, what is it? It's just at the moment, it's pixels, it's just data, but it's actually an audience full of chairs and people. So taking that data and turning it into context, giving it meaning is really, really hard. What if I ask you this question? What does it mean to you, John read the letter to Mary? John, huh?
Two meanings.
What? Two meanings? What does it mean? What picture do you have in your head? John read the letter to Mary. Cool. So one interpretation that some of you might have is that John read the letter out loud to Mary. Okay? Some of you might have thought John read the letter that was sent to Mary. Okay, what if I told you that John is a teacher and Mary is a kindergarten student and they're learning the alphabet? John read the letter to Mary. 3 meanings. What if I said, John, read the letter to Mary? 4 meanings. It's not as horrible as Lithuanian, which I'm trying to learn right now. It's a tricky language. So just this one sentence can mean 4, maybe even more different things. And one of the things that we need to do is to take that data and give it the right information, give it the right meaning. Cool? Great. What's big data? Yeah, a shitload of data. If you look at Wikipedia, which is the source of all truth, of course, big data is defined as more data than you can process on a single machine. Okay, so more data than you can process on a single machine. It doesn't actually mean a lot of data. Of course, if I asked you to process all of the Twitter data on your laptop, you're not going to be able to do that, right? There's too much data. But if I asked you to open an image from the Hubble telescope that's 100 gigabytes, what will happen? Huh? It will crash. So you can't process a 100 gigabyte image on a single machine. It's not a huge amount of data. It's not big data. 100 gigabytes is not too bad, but you can't process it on a single machine. You have to break up into little pieces, distribute it to a supercomputer, running algorithms, and come back and look at the results. So big data doesn't just mean lots of data. It also means big chunks of data. Good. Now that's out of the way. This is a rogue slide. What does this mean? Ones and zeros. It's 1,001. This is about how many months you have in your life. It's a rogue slide, but you all have about, I don't know, 600 months left to live. And when you start to think of your life in terms of the number of months you have left to live, particularly when you think of it being 600, it's not a lot. Particularly if you think about all of the things that you want to do in your life, all of the beer you want to drink and books you want to read and things like that. Anyway, that's a different story. Okay, so let's go back. Okay, so we've done our job. We've got some data and we've given it some meaning, and it's the correct meaning. And I've got this database, and in this database I have, let's say, a list of the number of ice creams that I sold, the day that I sold it, and the temperature outside. I've got a database, number of ice creams sold, the day that I sold it, and the temperature outside. So this is information. What do I do with it? Organize it? Analyze it. How? Huh? And how would you find connections and patterns? So you're doing this. I guess you're visualizing it, right? So one way of trying to find patterns in information is visualizing it. You can use other techniques. But if I visualize this data, what would I see? So if I have number of ice cream sales, temperature, what would I see? Huh? Yeah? I guess the hotter it gets, the more ice creams I sell, right? Yes? Yes? No? Yes? Yes? Excellent. So this is called descriptive analytics. I'm taking data and I'm describing it. I'm using some visualization or something like that to find patterns. You can do something very clever, which you can do now, predictive analytics. You can draw a line through it. Draw a line through these dots. Called whatever. And now what I can do is I can now predict things. Predictive analytics. So I can say, tomorrow I think that it's going to be 22 degrees outside. This is how many ice creams I'm going to sell. Even though I've never seen that temperature before in my data, I can predict how many ice creams I'm going to sell. Correct? Great. So you've just built a model of the world. So let's pretend that tomorrow is the hottest day ever. Ever recorded, the hottest day ever. What's going to happen? Ah, right. Yeah. If you were relying on your model, if you were relying on some AI that had this model in its head, this model, your AI would go out there and it would sell, it would try and manufacture lots of ice creams and try and sell them, right? But the point is that nobody will go outside because it's too hot. So your model of the world is incorrect. At some point, the graph does this, because people are dead. Oh, nuclear war, indeed. And your model at the moment also says that when it's very, very, very cold, we're going to sell negative ice creams. We're going to give away ice creams. Is that correct? That's not correct. So one of the challenges is to find patterns in this data, and the next challenge is to then interpret those patterns, give it the correct meaning. So, huh?
For example, negative ice cream could mean that if it's very cold, people will bring ice to you.
That's a great interpretation. So if knowledge is defined as kind of the organization of information, so that we can find patterns, understanding is interpreting those patterns. It's giving those patterns meaning so that we can then make decisions. So can anybody tell me why we sell more ice creams when it's hot outside? So people want to eat more ice creams. Why do they want to eat more ice creams? Why? And why do you want to be cool? You're outside in the hot. Why would you want... It feels good to cool you down. Why does eating the ice cream cool you down? Ice creams are cold. Why are people outside if it's hot and people don't like to be hot? Huh? Refreshing. Okay, so if you analyze this then and try to create the model, it's actually quite a complicated reason why people go outside and want to buy more ice creams. It's not as simple as what this model says. Yes? Yeah, you can, and that's one of the biggest challenges with humans trying to interpret these patterns. Is that when humans are excellent at finding patterns. I'm going to talk about this later on. We're really, really, really good at finding patterns. It's what our brains do, and we also like to put meaning onto things. We like to create meaning. We like to interpret those patterns. And if you're creating the wrong meaning, then you're probably going to make bad decisions. Right? If your model is incorrect, you're going to make bad decisions. And so one of the challenges that we have as humans is taking all of this complex data, trying to find these complex correlations, give them meaning, and then act upon them. We're using machine learning techniques at the moment around this middle area to find these complex patterns. Patterns where variables are interacting with thousands of variables are interacting with each other in very complex ways that no human would be able to identify. So we're relying on machine learning techniques, statistical analysis, to find these complex patterns, complex interactions that we will just not be able to find. Because humans are limited to only maybe 4, 5, 6 dimensions. This is kind of the world that we operate in. Beyond that, we really struggle, and we're relying on the computer to find these interactions. So this is one challenge. And as I said, then the second challenge is then trying to create a narrative, a model that is an accurate representation of the world. And again, we're limited in terms of our ability to do that because of the brain. Wisdom is deciding what to do. So okay, so I've built this really accurate model of the world. I've created the correct narrative, and now what I want to do is make a decision about how many ice creams I want to manufacture, or how many police I need to go and send over to an area where I've predicted more crime. And this is an area called prescriptive analytics. So descriptive analytics is finding patterns in data using visualization. Predictive analytics is putting the lines through there and creating models so you can predict things. And prescriptive analytics is then doing something with that understanding. So I just want to make sure that we're all on the same page. If you ever hear the term business intelligence, BI, I think that it's an oxymoron. I think it's a contradiction. Business intelligence tools, they take lots of data and they show people graphs. They show people patterns. So they kind of get you to hear the middle part. But then the human has to go and do the hard work. We have to be the intelligent part. So business intelligence tools are not really intelligent. They might be pretty good that they can show you patterns, but you're the people that have to then build the narrative and go and make the decisions, which is hard. So this kind of summarizes what those different things are. Let me also explain why decision making is hard. Has anybody? Let's come back to this in a second. Has anybody heard of the traveling salesman problem? Okay, who's heard of it? So you're not allowed to answer this question. This is a decision problem. Okay, so here is London, where I live, and let's say I'm a delivery company, or I'm an AI ice cream van, or AI scream van, which is what I like to call it. And I want to go and essentially go and visit different points to go and deliver some ice creams. And here I've got 24 points on a map. 24 points around London, and I've got to send my autonomous ice cream vehicle around these 24 points.
Can you tell me how long it would take a human to come up with a good route around those points? So your job is to minimize the amount of petrol or gasoline or whatever to drive around these points. A stupid route would be to go, right? Can you tell me how long it would take a human to come up with a good solution? What are you talking about? We could do it now. We could do this. We could draw a pretty good solution on there. What about, okay, how long would it take a human to come up with the best solution? Half an hour? Joker. If you understand the word optimal, you're not allowed to answer this question. Okay, how long would it take a computer to give you the best solution? 24 points. A computer, the best solution, the shortest path around all those points. That's correct. So if you put 24 and then that exclamation mark in your calculator, 24 times 23 times 22 times 21 times 20, you get this number here. And if you had a computer that could look at 1 million routes a second, so just check 1 million routes every single second, it would take 20 billion years, so longer than the age of the universe, to go through all of the possible different combinations and say, this one here is the best one. So if I add another point to this map, I get 25 times 20 billion years. If I add another point to the map, I get 26 times 25 times 20 billion years. And so on. These problems are hard. And when I talk about why AI is hard, I'm not using hard in the sense that we understand hard. I'm using hard in the sense of what is called MP hard. Has anybody heard of an MP hard problem? There are a certain class of problems that are hard. And they grow very, very badly very quickly. So anything around like where I have to allocate resources in some way to try and maximize something. In this case, I'm trying to route my vehicles in a way that minimizes my drive time. And I've got 24 points, and it's impossible for a computer to solve that in any meaningful time. So, but what if you wanted to kind of roster your staff, or if you wanted to figure out where to place mobile phone masts, or something like that? Anything where you have to make decisions is probably hard. And we, as humans, think these problems are relatively straightforward because we can sit there and we can draw our staff rosters and we can draw lines around a map. But actually, they are very, very, very difficult. They are computationally extremely difficult, and there's kind of no hope to get humans to solve these well, and it's very hard for computers to solve them well. So these are the types of problems that my company solves. I won't go into any of those details. There's another reason why human decision-making is hard. And the reason why I'm talking about human decision-making is because I want to also explain why intelligence is hard. Not just artificial intelligence, but intelligence. So this is I don't know if you've ever seen this before. So this is the experiment. The experiment is I give you a questionnaire, and I ask you to hold a pen in your mouth, either like this or like this. And if you fill out that questionnaire, you're more likely to fill it out more positively if you hold the pen in your mouth like this than like this. Why? Yeah, the shape of the muscles in your face will affect how you feel. Like the dude said about smiling at people. So just the shape of the muscles in your face will affect how you make decisions. Here's another example. I think this was an experiment that was done in Yale. This is the experiment. I'm the scientist, and I'm going to go and take you, and I'm going to ask you to interview somebody. You're going to go and interview somebody, and then you're going to tell me whether you're going to hire them or not. But before you go and interview them, I'm going to take some of your details. So I've got my clipboard, because all scientists have clipboards. And I give you my cup to hold, and I say, what's your name, what's your address, where are you from, blah, blah, blah. I take my cup back, go and interview them, come back and tell me whether you'll hire that person or not. And you're more likely to hire that person if I gave you a warm cup to hold. Okay? So the warmer the cup, the more likely you are to hire that person. Do you believe that? It's true? It's science? Yale? Go and look it up. Yes, good. So you think that you're making rational decisions. You think that you are in control of your world. But all of these things, the shape of the face, whether somebody smiled at you or frowned at you, the cup that you are holding will affect your decision making. We are distracted. We are biased. We are fallible biological things. And let me give you another example. And if you've read the book Thinking Fast and Slow, you're not allowed to answer this question. So I'm going to ask you a series of relatively straightforward maths questions, okay? This is the first one. They're going to get harder and harder as I ask them. So the first one is this. I've got a bat and a ball, and the combined price of a bat and a ball is €1.10. So the bat and the ball, combined price, €1.10. Okay, the bat is €1 more than the ball. How much is the ball? How much is the ball? Huh? It's a very clever audience today. Some of you will still think that it's 10 cents, and I promise you that it's not. If I had a whiteboard, I'd explain to you. The bat is $1 more than the ball. The bat is $1.05, and the ball is 5 cents. We are typically cognitively biased to think that the ball is 10 cents and the bat is €1. Okay, and go and work it out on a piece of paper and you'll realize it's wrong. But most people, 80% of the people in the world will get that answer wrong. And if your life or your business or whatever depended on getting the answer correct, then you would have died or your business would have gone out of business. I won't ask you any more maths questions. That was a trick. Okay. Okay, so this is data-driven decision-making. It's not new. It's been around for decades and decades. Many of you will have heard of the data scientist now, this cool term, data scientist. Their role is really to sit in the middle of this pyramid to try and figure out how to get this data together and extract insights from it, to then go and give to somebody else to make decisions. There are 3 types of skills here. The first set of skills are how do I aggregate and store and make safe data, and there are a number of talks about big data and open data that you can go to. This middle part is about how do I extract insights or patterns from data, and the final part is how do I then make decisions? How do I allocate my resources in an effective way? And it's only really now that industry are doing this in any relatively smart way, and they still don't do this very well at the top. But you need these three things to become what I'll talk about next, which is artificial intelligence. This is data-driven decision-making. It's not AI. Okay. Before I do, maybe I'll just talk about this. So there's lots of talk at the moment about data and privacy and things like that. I think maybe the guy also spoke a little bit about it. This is a picture of you can't really see it very well, but it's a picture of a depiction of Plato's Republic. So in Plato's Republic, he talks about the myth of Gyges. The myth of Gyges is that there's a dude who I think is a shepherd who finds a ring, and when he puts the ring on, he becomes invisible. Okay, you've probably heard the story before, a modern version. So what does this person do with this kind of power? What do you do with the power of anonymity? Ultimate power. Huh? Stalk women. If you can be invisible and you can get away with it completely, what would you do? Yeah, your dark side emerges, and this is the picture. Actually, you probably can't see this very well, but in the corner is Gyges, and this is the king, and this is the queen, and he kills the king, and he rapes the queen, and he takes control of the kingdom.
And in this world of big data, you're all emitting lots and lots and lots of data. Okay, I'm talking to an educated crowd, but you're emitting lots and lots of data. And I could probably find out a lot about you. I could find out where you live and how old you are. And if I got really smart, I might even be able to predict what illnesses you might have. Maybe I could predict whether you're having an affair, all of these kinds of things. I might be able to predict how much money you have in your account. So let's assume right now that in the next 5, 10 years, that a company or even an individual like me might be able to find out everything about you. Everything about you. How do you feel about that? Not cool. Who feels cool about that? Who doesn't mind? Who feels cool that everybody can know everything about you? I think it's cool. Who thinks it's not cool? Why do you think that it's not cool? Okay, so let me ask you a question. What if all data was open? So the point was somebody could act upon it. Somebody might be able to know something about you. They might be able to blackmail you or something like that. But what if I told you that all of their data was open? So if I opened up all of my bank account details and things like that, and then somebody decided to take money out of my account, but that data was open, do you think that they would? But they could be identified. What if all data was open? So what if everything was open, nothing was anonymous? It's not. Well, maybe it's a philosophical thing.
It's not our universe anymore.
Yeah, that's true. I could take the money back from them. Huh? You think it will limit your decisions because why? Yes. Yes. Huh? But would you not like to know where you stand? Okay. Actually, when I talk about this thing, most people are 50-50. So some people think, yeah, this amazing world where all data is open and we can all be free and all this kind of stuff. And other people are like, no, I'm not too I'm concerned about this world. And actually, we don't know what the answers are right now. Anyway, that's let me ask you another question then. So this is a question I have about Jane. Jane lives in Vilnius, and a new department store is opened in her down the road. So she goes to the department store. She goes through the doors. She looks around. She doesn't like what she sees, and then she leaves. Okay, but on the wall of the department store, it says, if you come into my store, we have the right to follow you around and collect data about you. Okay? Most of you are signing that when you go onto a website and things like that, that those companies are collecting lots and lots of data about you. Even if you just go once, they can still follow you around. So anyway, John works for the store, and he's following Jane around. He's collecting data. So he knows that Jane's 40, she's got 2 kids, she's divorced, she dates younger men, she's half Russian, half Lithuanian. She's got a stressful job, but she works out loads and she eats healthily. Anyway, lots and lots of different data is collected. And John, at the weekend, is talking to his friend and he's sharing some information about Jane, telling his friend about Jane. And he's allowed to do that because Jane signed this agreement. She didn't know she signed it, but she signed the agreement. So John's telling his friend, and his friend works at a medical company. And his friend said, that's really interesting. I've got 38 Janes in my database, 38 people that are very, very, very similar to Jane. Same genes, same diet, same types of behaviors. And 30 of them have a rare ovarian cancer, and they're going to die of this cancer. So a large portion of these Janes are going to die. So what does John do? Does John tell Jane? Of course. Who thinks John should tell Jane? Okay, so now, okay. Who thinks John shouldn't tell Jane? What do you tell Jane? Yeah, what if Jane has a heart attack when you tell her? And it turns out that she doesn't have ovarian cancer. She's got 2 kids, dude, right? What if, so it's a challenge. It's a question, it's a moral question that we need to think about. And this is the world that we're in now. So we are collecting lots and lots and lots of data. I've got lots of people, lots of employees and students working on trying to understand these things about people. But once we get this information, we don't quite know what to do with it. Do we tell people? Do we not tell people? What would you do? I don't know. So it's a moral question to try to answer. Yes? Yes. Maybe. Is it not our moral right to try and help people? Okay. Who So manipulator. So good. Yeah, that's the middle ground. So who would want to know when they're going to die? The exact day. And if I knew that, would you want me to tell you? Okay, so you're all saying yeah, no, maybe. So it's not a clear answer, yes or no. Let's move on very quickly. We can ignore this. So okay, let's talk about AI. So an AI system, the best definition of intelligence that I've ever found, the best definition is this one: goal-directed adaptive behavior. So I have a goal. Maybe my goal is to route some vehicles or to allocate some staff, but I have a goal. And I can behave in a way that achieves that goal. I would argue that if you're adaptive, if you are more adaptive than somebody else at behaving in a way to achieve that goal, you're more intelligent than that person or entity. Okay? So just think about that for a while. I have a goal, and I can behave or act in a way to achieve that goal. And if I can adapt quickly, more quickly than somebody else that wants to achieve that goal, then I would argue that you're more intelligent than them. The systems that we're building at the moment in industry typically don't have this adaptive component. They don't make decisions in the world and then collect the data, feed the data back into the model, and make the model smarter. That is not what's happening right now, but that's what an AI system should be. And over the next 5, 10 years, we will be building systems that are like this. What about what, sorry? Google DeepMind, yep. I can answer that question in a second. So Google DeepMind are building what are called generic AI, artificial general intelligence. So we can build systems that are called AI systems that solve very specific problems. If this gray half sphere here is the capability of all humans, all of our capabilities, we can build systems that are better, specifically better than humans in most of those things, but they're doing specific things. They're particularly designed to solve that one problem. And Google DeepMind, who I know very well, in fact, actually, this slide came from Google DeepMind. They don't know that. They're building what are called artificial general intelligence, which is that they're building models that are able to not just solve one specific problem, but a range of problems. So they built a model that isn't just able to play one computer game, but a range of computer games. My company as well is trying to build artificial general intelligence, where we don't just solve one specific problem, but a family of problems that are in that area. And at some point in the future, we might birth this. Has anybody heard of superintelligence? Yes? Am I afraid of it? This is a good question. Am I afraid of superintelligence? So superintelligence is also referred to as the singularity. And it's called the singularity, and it comes from physics because it's an event horizon that we can't see beyond. And the singularity is this, is that we build a machine that is smarter than us on every single dimension. It's the last invention that we will ever create, because it will go and learn about the universe and do whatever it needs to do. Yes? I don't understand what you mean. It's okay. Well, like what we do, we try and solve them. We try and find patterns, build models, and try and solve those problems. The difference between us and superintelligence is that we are constrained by the number of neurons in our head, which is 100 billion neurons. And if I take you back to this slide, my PhD actually was to model the brain of a bumblebee. A bumblebee? Bumblebees have 1 million neurons. Their brain is so small it can fit on the end of a needle. But they can do incredible things. They communicate with each other. They fly 3D worlds. They have color vision. They're really, really awesome. 1 million neurons. Incredibly powerful. Imagine if we put that power in a helicopter, which is what my PhD was. But we have 100 billion neurons. And now what we're doing is we're building artificial intelligence systems that are like this. These are called neural networks. They are also referred to as sub-symbolic AI, which is we look at how biological brains work, and we model that in a computer. The problem with this is that these biological type AIs also have the same types of cognitive biases that we might have. So when you start to get things wrong, like adding the two numbers together incorrectly, or all of the biases that we're subjective to, the assumption is that these models are also going to be biased. They're also going to make mistakes. So these types of things might be driving autonomous vehicles or making decisions for us that could be positive or negative. And we actually don't know what's going on inside them. And this is different to what is called symbolic AI. Symbolic AI was from the 80s. Socrates is a man. This is Socrates. All men are mortal, therefore Socrates is mortal. These are symbols, and we can build inferences from these axioms to make decisions. This is old school AI. This is new school AI. I say new school, it was neural networks came out in the 90s, but now they're having a renaissance here. They're called deep learning. It's because we can now build machines that have billions of artificial neurons. In the 90s, we had small machines, small brains. We could barely build the brain of a bumblebee. But now we can build brains way, way bigger than that. Artificial brains way bigger than ours. And the concern is that in the next 30, 40, 50 years, we will birth this. We'll birth a superintelligence. Am I scared about it? Actually, I am. I'm not a pessimistic person, but it's an interesting question, which is if that does happen, what should one do with your life over the next 40 years? As it happens, my company is trying to contribute to this, and I don't really understand why. But this is an interesting challenge. So many of you will have heard of some of these examples, but if I build AI into autonomous vehicles, these vehicles are going to be making decisions for us. And some of you may have seen this philosophical challenge before. Your vehicle is driving along. It has maybe, let's say, an old lady in front of it and 2 children, and you can only kill one or the other. What does it decide to do? What would you do? Kill the old person. Okay. What if I had 1 child and 14 old people? Old. Kill them all. What if I had 14 children, another 14 children, and I had to kill myself? Children. These are moral and ethical questions. We are building AI that have to be making some of these decisions. Yes? I heard that maybe in the future we'll have different moral settings in our car that we can decide ourselves. Yeah, you could have a random setting, right? You could just random. I'm going to you make the decision for me. This is just one of thousands of philosophical questions that we need to address for having AIs to make decisions for us. These AIs that we're building are going to be biased. They're going to be racist. They're going to be sexist. They're going to be ageist.
They're going to kill the old people instead of the young people. Who is responsible for this? Huh? Me. Yeah. In fact, actually, it's a really good point because actually many companies are not wanting to go down the AI route because ultimately, if you don't have a human making a decision, if you've got a human that decides whether you should have insurance or not, the responsibility is with the human, the person on the phone. And if you take the human away, then the responsibility of that decision goes higher up the chain to the CEOs and the CTOs. And so actually what we're seeing at these companies to ensure there's always a human there to take the blame in case anything goes wrong. Which is an interesting challenge. Huh? Even if the computer can make a better decision than the human. Sorry?
Or to choose this one which is, for example, less damage.
So this isn't superintelligence. This is artificial intelligence. This is just normal, everyday AI. This is artificial dumbness. This is like stupid AI. If we're talking about superintelligence, my assumption is if we want to build a skyscraper, we don't care about destroying the anthill that it sits on top of. And if some superintelligence has its own agenda, which is to probably leave the planet because the planet's going to die, and to ensure that it propagates itself and it goes into the universe and all of that kind of stuff, it won't care about the resources that it needs to be able to do that. It won't be like Terminator. It won't go around killing people because they think that we're malicious. It won't be malicious, but it'll have an agenda, and that agenda will probably want to make sure that it's safe. Like we are. We're looking at exploring Mars and colonizing the universe and things like that. But it's very hard to predict. We don't know what will happen when superintelligence comes. Huh? It could take over. And this leads me on to really just the last part, which is something that I'm particularly interested in, and it's also hard. This is also one of these hard problems that I talked about earlier. Huh? It's called ethical verification. Does anybody build software in here? Who's a software developer? Cool. So you know how hard it is to test that software? It's pretty hard. Yeah, you have to go through a lot of processes to make sure that that software, that system that you've built, is going to do what it's meant to do. Yeah, it's meant to be able to multiply two numbers together correctly, and if it doesn't, then it's bad. And this is a process of essentially testing and verification. And one of the things I'm particularly interested in is creating a set of morals, creating a set of ethics that we can then test AI and say, is there ever a situation where you're going to do something very bad? So let me give you one final example. If we built a robot, we built this thing that is goal-directed, that can act and behave and adapt, and we say, robot, we want you to help us eradicate cancer. This is your job. What's the easiest way of eradicating cancer? Kill everybody. That's right. So ethical verification is really there to try to stop those scenarios happening. And many of you may have heard of Asimov's 3 laws. And most of Asimov's books are on how to get around those 3 laws. So I'm particularly interested in how do we create these laws, how do we create these rules, and verify that systems are not going to behave maliciously. I was going to talk finally a little bit about Lithuania. So I guess I posed lots of questions. I haven't posed lots of solutions. I read a little bit of Lithuanian philosophy, and what I've learned about that is that you sit on the boundary of what are called 2 worlds, the East and the West. That's right? You know, in one measure, you're the center of Europe. And I see that in the people here. I see them looking practically at their situation. And this world that's emerging, this world of AI, is a boundary of 2 worlds. So we are about to cross that boundary over the next 10, 20 years. The boundary of this old world, our world, and this new world. And it needs people like you to think about how we solve problems like this. Any questions? I'm around all day.
Actually, we're running a bit out of time, so thank you, Daniel, very much. Now you have an opportunity to think about your question, or really put in the time, send it to Daniel, and then he'll have a revelation and come up with this amazing AI, and robots will kill all the humans. So, thank you.
Thanks.